Okay, so this is our second lesson for our inequalities unit. And today we're going to be focusing on testing solutions, writing inequalities from sentences, learning those keywords, and then how to graph a solution. All right, so a couple things going on in today's lesson. All right, so in order to be able to write an inequality, you have to understand the keywords. All right, so there are some that are obvious and some that are not so obvious. Greater than and more than, clearly that's your greater than symbol. Less than and fewer than, that's your less than. Then you get to the equal to part. Okay, so how do I know that it's equal to, meaning that the solution can be that number? It's this line that you see underneath the symbol. Okay, that means if it's greater than or equal to 5, then 5 can be a part of that solution. So you need to remember at least, no less than, and minimum, okay? More than or equal to, that's a given. But if I say you have to be, I'll go back to the roller coaster example from day one, at least 48 inches, that means that all acceptable solutions or heights must be greater than 48 inches. If you say you have to be at least 13 years old to go to the movies by yourself, then that would mean ages greater than 13 would be acceptable. Okay, so then we have less than or equal to. Our keywords here: at most, no more than, and a maximum. All right, so circle this on your notes if you printed them out. These keywords are really important for you guys to remember. If I say you can be at most 4 years old to play in the toddler zone, then 4 is the highest value or highest age value that you can be. All right, so the more we practice this and the more you can put it into a scenario, the easier these keywords and these symbols will be. Okay, so when we're writing a sentence as an inequality, we're looking for those keywords. When I read the sentence, I'm looking for a keyword that tells me what inequality belongs there. All right, so if I say a number x is less than 2, do you see the keyword that tells you the symbol? You should be looking at less than. Okay, so a number x is what I don't know, is less than 2. So to tie it into what we just talked about, what number would be an acceptable value for x that would make this true? You should be thinking of a number less than 2, right? 1, 0, -1, -2. And to infinity, right? Like any negative number would make that true. So that's what makes it an inequality. There's not just one number that makes it true. Okay, a number m plus 4 is greater than or equal to 7. All right, look for that keyword. Did you see greater than or equal to? All right. So now, how would we write a number plus 4? And notice the variable it's asking us to use. Hopefully you're thinking m plus 4, right? Okay, so we don't need to overthink this. Is greater than, so it's open to that side because it's greater than, or equal to. Remember, this bar underneath means that it can be equal to 7. Okay, so, and again, is there more than one number I could add to 4 and the sum of these two would be greater than 7? Absolutely. Could I say m value of 5? What's 5 plus 4? It's 9, right? 9 is greater than or equal to 7. But could I say 2? 2 plus 4, is that greater than 7? No. Okay? So what we're doing here is we're setting up an inequality, but again, what I want you to understand is there are honestly an infinite number of numbers that can make this inequality true. So that's where you can give m whatever value you would want, okay? As long as it would end up being greater than 7. Okay, so 10 is no less than, so this is one of the tricky ones. It's no less than a number, q, multiplied by 6. All right, so again, you have to remember, if I say something can be no less than, all right, you can be no less than 18 to vote. Okay, well, no less than means it can't be below that number. Okay, so 10 is greater than, because it can't be any less than, a number q multiplied by 6. So how could I show a variable being multiplied by a number? Hopefully you're saying 6q, right? We always write the number first. So we say 6q. We don't have to solve these. We're just writing the inequality for now. We will solve them eventually. We're just not solving them right now. Okay, so testing solutions. Just like in the last slide, we said, I could plug in a value for m, 9 or 10 or something to make it true. All they're doing here is they're giving us a value, and they're saying, what happens if you plug in this value? Does it make the inequality true? All right, so I need you to show your substitution. Plug in 2 for u. 2 plus 7 is less than 4. So what is 2 plus 7? I need you to show this work. I need you to write it down. 9 is less than 4. Is that true? No. So what does that mean? 2 is not a solution. There are many solutions. I'm sure you could probably think of one. Okay, so let's try. What number plus 7 would be less than 4? All right, so this is a little tricky, but it's most negative numbers, right? What about negative 10? Negative 10 plus 7 is negative 3, and that's less than 4. So that's not really part of the problem, but I just want you to understand you're not necessarily solving anything, you're just testing a possible solution. They're just throwing numbers out there. All right, so let's look at this next one. P equals 6. Plug in 6 for P. Does it make the inequality true? So, what is it? What operation's happening here? All right, hopefully you're saying multiplication. So 5 times 6 is greater than or equal to 24. What is 5 times 6? 30. Is it true that 30 is greater than or equal to 24? Yes. 6 is a solution. Is it the only solution? Absolutely not. But it's one of them. All right. So again, we're testing solutions, but your proof is in your work. All right, and you know that I'm going to be asking for work every once in a while. So it's important, especially on your test, it's important that you're practicing showing your work, even on your homework assignments, and especially on your quizzes and tests. Okay, last one, x equals 10. So again, we plug it in for x in the inequality and we test it. Negative 3 is less than negative 10 over 5. So negative 3 is less than negative 2. Is that true? Is negative 3 less than negative 2? It is, because remember, it's farther from 0. The larger the negative number, the smaller its value. So yes, 10 is a solution. All right, I want the whole sentence because you're telling me that you understand what the answer is. That 10 can be a part of the solution here. All right, just testing solutions. Okay, so now graphing inequalities. In order to graph them, we're going to use number lines. So this is very, very important for inequalities. You may have learned this maybe in a different math class, maybe last year or the year before. But to graph an inequality on a number line, we're showing this is the cutoff point, and then everything either greater or less than this number would make the inequality true. I need 3 numbers on your number line. The middle number is always your solution, okay? Or the number that's in your solution. So in this case, 3. Now I need 1 number less than 3. 2. Now I need 1 number greater than 3. 4. Okay, you see what we did there? So we just created a number line, but this starting number is always our middle number. Okay, so now, would it be an open dot or a closed dot? All right, it's an open dot. Okay, and how do I know that? Because, and I guess probably at this point we have not talked about it, so I need to give you some background. If it's just a less than or a greater than sign, and actually none of them are equal to, so I'll change that too. If it's just a less than sign, meaning it does not have the line underneath, it will be an open dot. So actually I want you to write that on your notes. Open dot means less than or greater than. A closed dot, so it's like a colored in dot like this, means less than or equal to or greater than or equal to. So it has that equal to bar underneath. That's how you know if it's an open dot or a closed dot. Okay, so we know it's an open dot because it's just less than. And remember, it's all solutions. All numbers less than 3 would make this inequality true. So I'm going to draw my arrow. I'm just going to make it thicker right here. And I'm going to draw my arrow going left, just like this. Okay, draw my arrow going left. Less than 3. Okay, so, and that's, that's how I would graph that solution. All right, so now let's look at this one. What you might notice about this one is that it's written backwards, which with inequalities, that's an issue because it could cause us to read this inequality symbol wrong. Because when we look at this, we think less than, but it's actually not. So what I want you to do is notice how it's open towards the variable. You see that? And I want you to rewrite it. Now t is greater than, so it's still open towards the variable. Just like it was open towards the variable here, it's still open towards the variable down here. T is greater than -3. Now that I'm reading this, we can kind of call it reading it forward. Now we can graph it on a number line. Okay, what is your middle number going to be? If you're saying -3, you're right. Now with negative numbers, we have to be careful on the graph. What is one number less than -3? Think negatives. Hopefully you're thinking -4 because I'm going away from 0. What's one number greater than -3? -2. All right, so this will be an open dot, again, because there's no equal to. And now t means all numbers. All numbers greater than -3 will make the inequality true. So greater than means that my values are all getting bigger to the right. So I want you to make it real nice and dark and then draw an arrow on the end. greater than -3. All right, last one. Let's make this one equal to so we can see the difference there. All right, so just draw an equal to symbol underneath. All right, what number goes in the middle? Hopefully you're saying -4. To the left, -5. To the right, -3. Okay, so now, because we added that equal to symbol, it's going to be a closed dot here. And what this means is that my solution can be -4, that it could be equal to -4 to still make it true. But then all solutions must be less than, which means which way would your arrow go? Hopefully you're saying to the left. All solutions less than -4 would make this true. Okay, so that's how you're going to graph a solution. So from here on out, when you solve inequalities, you're always going to graph the solution. All right, so that's really important. Okay, modeling real life. We're going to kind of end with a bang on this one. Okay, so it's real important, going back to those real life scenarios, that we understand there's going to be a cutoff, but then acceptable answers could be greater than or less than whatever that cutoff number is. So it says there are 65 people in a restaurant. The restaurant has a maximum capacity of 84 people, so it's important. You always want to be able to pick out what is the total amount. All right, so for all three of these, there's going to be some kind of a total amount that I'm comparing my values to. All right, because an inequality is a comparison. Is it less than or greater than some other amount? So it says the restaurant has a maximum capacity of 84 people. Write an inequality that represents the number of additional people, that can be X, who can enter the restaurant. Okay, so we're always going to start with our total. In this case, it's 84. There can be 84 people. But the combination of values, okay, so we know 65 is over here on this side, plus I don't know how many people. So the operation is always connected to our variable. How did I know it was plus? Because I'm adding people. All right, so how does this value need to compare to 84? Does it need to be less than? Could it be less than or equal to? Or does it need to be greater than or equal to? Okay, so if you're thinking this combination needs to be less than, you're correct. But what if there are 84 people in the restaurant? Are we still okay? The answer is yes. So that's how you know that you need to put the equal to symbol in there. All right, and we're just going to leave it there. We're not going to solve it until our lesson tomorrow. Okay, so let's look at the next one. To qualify for an award, a student who volunteers no less than 5 hours each week at the local hospital can qualify. So write an inequality that represents how many hours the student volunteers each week. All right, so H can stand for hours. It doesn't say that they've already volunteered a certain number of hours, so it's just going to be H. And remember, you're always comparing it to some total that the problem has to give you. So how do the hours need to compare to 5? 5 is my cutoff. Do the hours need to be less than 5 or greater than 5? What does no less than mean? No less than means that the hours must be greater than or equal to 5. If I say you have to study for no less than 2 hours, that means 2 hours is the absolute minimum. That means the acceptable study time has to be more than that. That's what it's saying here. The acceptable number of hours that you volunteer has to be more than the cutoff of 5. But if you do 5, even though it's the bare minimum, you would be okay. All right, so hopefully you're catching on to how I can kind of take a situation and write it into an inequality. So here we go on the last problem. The largest alligator ever caught in Mississippi weighed 727 pounds. Write an inequality that represents the weights of every other alligator that's ever been caught. So again, well, I don't know. I will pause it real quick and see if you can set up your inequality. All right, I'm going to use A for alligator. How does every other alligator compare to the 727 record? What symbol would go there? It's less than, right? Is it equal to? If another alligator weighed 727 pounds, would that have broken a record? No, it would have tied it. So it's just less than. Every other alligator is less than the record. So, let's answer this question. Would 750 be a solution to this inequality if there was another alligator caught? Okay, is 750 less than 727? Absolutely not. That would be a new record. So no, 750 is not a solution. Okay, so again, it's just breaking down basically what you're comparing. There's always a value you're comparing to, okay? And how do the acceptable answers compare to that number? All right, and with that, we're going to end our second lesson. Let me just double check. Yes. All right, we are done with day 2.